Something above your head just trained an AI model, and nobody down here plugged it in. No building, no cooling towers, no power bill from your local grid. Just a small satellite in low Earth orbit, running an Nvidia GPU, doing the same kind of math your phone leans on every time you ask it something. The company behind it is a startup called StarCloud, and they say this is the first time an AI model has been trained in space, which sounds like a stunt. And honestly, part of it is. But the reason Nvidia and a handful of very rich companies care about this is stranger than the headline, and it starts with a problem nobody can solve on the ground. So here's what actually happened, without the space movie music. StarCloud, a company that came out of the Nvidia Inception startup program, launched a small satellite carrying an Nvidia H100 GPU. That's the same class of chips sitting in racks inside the data centers that train the big commercial models. It went up on a SpaceX rideshare launch, and once it was operating, StarCloud and Nvidia announced that a model had been trained on board, in orbit, using that GPU. Nvidia framed it as the first AI training done in space. Not a giant model, not a GPT competitor. A demonstration. And that word, demonstration, is doing a lot of work here. Because a demonstration is how this whole industry moves. Somebody proves the boring version works, and then the money shows up. StarCloud's actual pitch isn't one satellite. It's data centers in orbit. Big ones. Solar-powered clusters of GPUs flying in formation, doing the training and the number crunching that currently happens in warehouses outside Phoenix and Dublin and Northern Virginia. And before you write that off as science fiction, Google has publicly talked about a similar idea with a project called Suncatcher, exploring TPU chips in space. Jeff Bezos has said out loud he thinks gigawatt-scale data centers in orbit are coming. So why would anyone want that? The answer is not romance. It's electricity. Think about what a data center really is. Strip away the branding, and it's a room full of chips that eat power and produce heat. That's it. 2 inputs, 1 waste product. You need enormous, steady electricity, and you need somewhere to dump the heat before the chips cook themselves. On Earth, both of those are getting expensive and politically messy. Utilities are pushing back. Towns are voting no. Grid connections have waiting lists measured in years. So the space argument goes like this. In the right orbit, sunlight is basically always available. No clouds, no night, no weather. You point solar panels at the sun and you get power without a substation, without a permit hearing, without a neighbor. Now the cooling part, because this is where most people's intuition goes wrong. Space is cold, sure, but it's also empty, and empty means there's no air to carry heat away. You can't put a fan in a vacuum and expect anything to happen. So, an orbital data center can't cool the way your laptop does. It has to radiate. You build big flat panels, you pump the heat out to them, and they glow it away as infrared light into the dark. It works. Spacecraft have done it for decades. It's just heavy and it's big, and the more chips you fly, the more radiator you have to fly with them. Which brings up the obvious question everyone skips. How do you get any of this up there without spending more than the data center is worth? For most of the last 40 years, the answer was, you don't. Launch cost killed the idea before anyone finished the spreadsheet. What changed is reusable rockets. Cost per kilogram to orbit has dropped hard, and companies are betting it keeps dropping as bigger vehicles come online. StarCloud's own public argument is that above some launch price, hauling GPUs to orbit and running them on free sunlight beats fighting for grid power on Earth. Whether that math holds is genuinely unproven. Nobody's operated a real orbital compute cluster for years on end. But the fact that Nvidia put its name near it tells you the industry no longer thinks it's silly. So what does this have to do with you, sitting there with a phone in your hand? More than you'd think. Every time you use an AI feature, something in a data center burns power on your behalf. That cost gets passed along in subscription prices, in what free tiers are allowed to do, in how fast a model answers you. And the reason your electricity bill and your AI bill are quietly connected is that both are pulling from the same strained grid. If compute moves off that grid, even partly, the pressure changes. If it doesn't, the fight over power gets uglier, and you're in it whether you use AI or not. If you're the kind of person who wants the real mechanics instead of the press release version, subscribe, because I do this every week, and this stuff is about to get loud. Now, the other thing that touches you directly is data. StarCloud has talked about processing satellite imagery in orbit instead of beaming raw pictures down to be analyzed later. Earth observation satellites collect far more than they can transmit. So a lot of it just gets thrown away or sits in a queue for hours. Put a GPU next to the camera and the satellite can decide what matters before it ever calls home. That sounds efficient. It's also a surveillance upgrade, and nobody's really discussed which one it is. Let's talk winners. Nvidia wins no matter what, because whether the chips end up in Nevada or in orbit, they're Nvidia chips. And every new place to put a GPU is a new market. Launch companies win because someone has to fly all that hardware. Startups like StarCloud win attention, which in this business converts straight into funding. And places that host huge data centers and hate it, communities fighting over water and power and noise, they'd love this to work. There's a real argument that moving heavy compute off the planet takes pressure off local grids. But there's a loser side to this, and it's not who you'd expect. The people with the most to lose are the ones who already sank billions into land, transformers, and buildings on the ground. Not immediately, because nothing is replacing a terrestrial data center this decade. But if orbital compute ever gets cheap for the heavy, batch-style work, like training runs that don't care about a few hundred milliseconds of delay, then some of that ground capacity becomes less special. And the honest catch cuts the other way too, because orbit is a brutal place to keep a computer alive. And this is where the enthusiasm usually stops short. Radiation is the first problem. Up there, high-energy particles flip bits in memory and slowly degrade chips. Data center GPUs were designed for a climate-controlled room, not for that. Space-grade electronics exist, but they run generations behind the fast stuff, which defeats the whole point. So companies have to either shield the good chips, accept errors, and correct them in software, or just plan on replacing hardware more often. Then there's maintenance. When a server dies in a building, someone walks over and swaps it. When it dies in orbit, that's it. And the third problem is the one that quietly breaks the business model. Bandwidth. A data center on Earth sits on fiber that carries staggering amounts of data. A satellite talks through radio or laser links, and those are far more limited. Optical links are improving fast, but you still can't shove a training data set through the sky the way you push it down a cable, which means orbital compute only makes sense for work where the data is already up there, like imagery, or where you send a small amount up, chew on it for a long time, and send a small answer back. That's a real niche. It's just a much narrower niche than a headline about space data centers suggests. And here's the part that reframes the whole story, the thing I think most coverage buried. The impressive bit of what StarCloud and Nvidia did isn't that a model got trained. Training a small model is not hard. The impressive bit is that a commercial, off-the-shelf H100, a chip built for a rack in a warehouse, survived launch and operated in orbit at all. That's the actual proof point. Because if standard data center hardware can work up there without being redesigned from scratch, the cost curve for every one of these projects changes. That's why Nvidia showed up. Not for the model, for the chip. So the guiding question, why do tech giants want data centers in space, has a pretty unglamorous answer. They're not chasing the stars. They're running out of places to plug in. Power and permits and cooling are the bottleneck on AI right now, more than chip supply, and orbit is one of the few directions nobody's already crowding. Whether it works at scale is genuinely open. Anyone telling you it's settled is selling something. What we have is one satellite, one GPU, and one demonstration that the hardware doesn't immediately die. Here's what I'd watch next, and it's not the next launch announcement. Watch for uptime. Watch for whether StarCloud or Google with Suncatcher publishes how long a commercial GPU actually keeps running in orbit before radiation or heat degrades it. Watch for someone reporting real cost per unit of compute delivered from space against a ground data center, and watch whether anyone flies a cluster instead of a single unit. Because linking multiple satellites into one machine is a completely different engineering problem than proving one chip survives. Those three signals will tell you if this is an industry or a very expensive demo. My honest read, space data centers won't replace the one serving your search results. But specialized compute in orbit, sitting next to cameras that are already up there, processing what they see before it ever reaches the ground, that feels close. And that's the version worth paying attention to because it changes what satellites can quietly do without asking anybody. If you want the next one of these, the messy real version, not the press release, follow along. I go through one real AI development a week and try to figure out what's actually true in it. And if you think I'm wrong about the launch cost math, tell me in the comments because I'd genuinely like to hear it.